Hi and welcome to Best Practices for Layers and Service Types with ArcGIS Enterprise. My name is Philip Heedy, and I'm the lead product manager for ArcGIS Enterprise. Together with my colleague Whit Mateau, over the next 45 minutes, I'm going to talk all about services, layers, and all the good stuff that goes into publishing your data and making use of it with ArcGIS Enterprise. We'll start with a quick overview and introduction of the various concepts that go into this topic. We'll get into some technical foundation, some key things to understand before you delve too deeply into this. Then we'll talk about GIS services and the concepts that go into that. And then we'll get into specific GIS service types. We'll round it out by talking about web maps and layers, that information model that sits on top of our web services, and then try to wrap things up. Whit and I have been doing this presentation in one form or another for a couple of years now. And we've always had this disclaimer that is evergreen and true. This topic is quite nuanced. There's a lot of detail. And this presentation is current as of March 2021 and the upcoming ArcGIS Enterprise 10.9 release. At the time of the presentation, 10.9 isn't out quite yet. But if you're watching a little bit later on, maybe it's there and you will be able to take advantage of some of the new things that we're going to be talking about. If you're watching this presentation on demand in, let's say, 2022 or sometime beyond that, I encourage you to find a newer version of the presentation to ensure that you have the latest information to work with. All right, let's get into it. In this section, I'm going to be talking a bit about some of the initial conceptual components of working with the web services that ArcGIS Enterprise exposes. When you're looking at the full stack, at the bottom we have data. This is typically your enterprise geodatabases. It might be something like shapefiles, file geodatabases, some kind of spatial data that you're looking to take advantage of in a connected application. This might be a web application. It might be a native application of some kind. To take that data, we've got it in some kind of storage. It might be file-based or databases. And then we have these services that sit on top to actually expose the data as web services that we can take advantage of, that we can connect to. On top sits the information model. This is really what the ArcGIS Enterprise portal brings to the game. There's these items, things like web maps and so forth, sitting on top. And then we've got a user experience of some kind, what our end users are actually taking advantage of, that application that maybe you've built or that Esri has built or one of our business partners. So when we translate those tiers over, you can really see the same components of the ArcGIS product shine through. We've got things like enterprise geodatabases down at that data store tier. We've got things like ArcGIS Server and other kinds of GIS servers at the functionality tier. We've got the enterprise portal that I mentioned that exposes an information model that we can take advantage of. And then the apps at the end of the day. In this particular presentation, we'll focus mostly on the apps that you may be building as developers and the underlying GIS services that power those apps. We'll touch a bit on the portal as well, but not too much on the data store side. Trying to put this into context just to make it a little bit easier to relate to. Imagine you have a storm data set. This powers a set of storm services that you're publishing. They may be things like map services and feature services and so forth, things that we'll talk much more about here throughout the presentation. Those services are put into a map. That map is exposed through the portal as a web map item that your storm viewer app, a web application that you may be building using something like the ArcGIS API for JavaScript, makes use of that map that ultimately references a series of services that actually expose the geospatial functionality. So keep these conceptual components in mind throughout the presentation. When you're building an application or a solution of some kind, there's a number of initial considerations to always keep in mind. This will drive how you actually author not just the app itself and the user experience, but also the underlying data and the services that will power your app. You have to keep in mind your audience, where they are. Are they sitting in an office? Are they in the field? What kind of device are they using? Is it a tablet? Is it a laptop? Is it a desktop? Or is it some even smaller, lower powered mobile device? What capabilities, what abilities do these have? What kind of performance do you need to be able to keep up? There's a big difference between an end user application that a human being is interacting with versus a back office system that's running in a batch mode throughout the night. Do you need to be able to scale the system up or out? Up meaning adding more capacity to existing infrastructure, or out by adding additional infrastructure, additional machines probably to your deployment? What kind of SLAs, service level agreements, do you have to your end users, the reliability that they're looking for? And finally, what security requirements? All of these different things have a big impact on architecture of apps as well as services and data. Consider, for example, this application where we're being asked to create a public-facing, highly available power outage app. That's something that's going to be used by a broad public audience, lots of non-GIS users. This is just the general public. And they're looking for information about when their power might go out, so it cannot go down. This needs to be available 24/7, 365. And compare and contrast that to an application made maybe by the same electrical utility company, but for an internal audience, their own employees, who are going out into the field collecting data. Sometimes they're on the internet, sometimes they're not, sometimes they have no connectivity at all. Imagine that there's a big difference in terms of both how to architect the application, but also how to architect the services to power such two very disparate applications created by potentially the same organization. So the approach here is to focus on the business. What problem are you trying to solve? Start with the end user in mind, the consumer of the application, and then build bottom up. Think of your data, the services on top of that data, and the web maps, and then the applications that will consume everything. Align and select the technology that will allow you to best solve your business problems. And then remember that things change over time. Be agile. Don't lock yourself into decisions that you can't ever undo or can only change with a significant effort. Make sure that you keep nimble if you think you may need that. All right. So now the technical foundation for this. Let's go back to those conceptual components and then really focus in on the two tiers in the middle. This is what makes up ArcGIS Enterprise, right? This is where you've got the enterprise portal and you've got the underlying GIS servers. That's what we're going to focus on here. When we're thinking of how to do this, there's a couple of things that you need to keep in mind. There's a couple of different ways to publish your services. The two primary ways are ArcGIS Pro and ArcMap. And I really want to make the case for switching to ArcGIS Pro if you haven't already for your publishing workflows. There's a lot of new capabilities that Pro allows you to take advantage of that ArcMap simply doesn't. Consider how to publish your data. Keep in mind that there's two related concepts here. There's the idea of hosted services, which is where ArcGIS manages not just the services, but also the data itself. You hand over your data to the system, and then we store it somehow internally. Versus the more traditional approach, which is user-managed data. Both of these workflows are completely fine depending on what it is you're trying to do. There's no one right or wrong answer. Sometimes we get questions whether Esri is trying to encourage or push data towards the ArcGIS managed model, and we're definitely not. It's simply an option. And then consider your data stores, which goes hand in hand with those hosted versus more traditional services, ArcGIS managed versus user managed. There's things like the ArcGIS data store, which is a component of ArcGIS Enterprise that provides those ArcGIS managed data options. And then there's data source that you register with ArcGIS Enterprise so that you can leave the data where it already exists and reference it in place. These are both the file-based options like file geodatabases and more traditional relational database options such as Oracle, SQL Server, Postgres, whether they're enterprise geodatabases or simply databases with spatially enabled tables in them. Great. So let's talk about these key concepts at the technical level. I'll talk about features versus map images. I'll talk about what we mean when we say tiles. I'll talk about various types of caching you can do within ArcGIS Enterprise to help speed things up, and then the general idea and concept of generalization. So let's talk about those features versus map images. Map images is really the original way of drawing in web applications in particular, but they're also used in many other types of applications. At its most fundamental, it's quite simple. You have a client of some kind that makes a request to the server where the client specifies the extent, meaning which area to draw, the size of the image that it wants returned, and the format of that image. For example, a PNG, a JPEG, and so forth. The server then takes that request and, based on its access to the data and so forth, draws what's being asked for by the client and returns a single image back. Hence the term map images, and sometimes you will see the idea of a map image layer. That's the item type that you'll find within the portal for these kinds of map services. So that's a very, very simple and straightforward way of working with the server and asking for something to be drawn. It's also one of the least flexible in many ways. But because it's so simple, it's very widely used even today, and it's also very widely supported by lots of different types of clients. One of the limitations of a map image is that you can't interact with the picture, because it is just that. It's just a picture of some kind of geography and what's in that area. You can't click on it and say, well, what is here? Because it's just a set of pixels. That's where features come in. The alternative to a map image is for the client to actually say, well, within this area, give me all of the features, all of the individual records at a certain location that maybe meets a certain set of requirements. You can specify a where clause, similar to doing a query against a SQL database, and specify which fields, just like with a SQL query against a database, you can specify that you only want some of the information that might be available for each record back. The server then takes that, talks to the underlying data store, and then returns those features that match the request to the client. Traditionally, that has been returned as a JSON format. More recently, you'll also see it being returned as protocol buffer format, which is a highly optimized binary format for sending data back in smaller packets and faster to the client. So keep these two terms in mind. But to really think about these two ways of doing it, one is server-side rendering. Those map images, the server is doing all of the work. You have a very small payload going back to the client. Those PNGs and JPEGs are typically no more than a few tens of kilobytes. Sometimes you might see hundreds of kilobytes. But the limitation is that client experience and the interactivity really isn't very high. On the other hand, with features, the client has to do more work, right? The client has to actually render those features, to draw them on the map, because it's not being handed an image. It needs to know how to interpret the data it gets back, and then also know how to draw. The payload going from the server to the client can vary quite widely in size. Sometimes you might get a very small response, but imagine you make a request for all of the records across the entire globe for a certain data set. You might get megabytes worth of data back. And that's something to keep in mind. That has a big impact on what kinds of clients you can use and the capabilities on that client. Does the browser or the app that you're using have the ability to deal with tens of megabytes of data? Is the network fast enough to actually transfer all that data in a way that your end users will appreciate. If they have to wait minutes for the data to be downloaded, it may not be a great experience. On the other hand, once you have all that data on the client, you have a very rich client experience, and you can interact with the data because the client actually knows about individual points, lines, and polygons and can highlight them and can do all kinds of very interesting things with them. Now, when we talk about tiles, you can imagine this pyramid. This is really something that was initially popularized by Google Maps, even though there were also some other earlier versions of this, but it's a way of splitting up the world, or at least the area of interest that you're looking at, into different levels of detail. So you can zoom very far out and cover the entire world with a single tile, or you can zoom in and you can start showing more data and splitting all that data up. It's possible to tile both raster and vector data. Traditionally, this was very, very heavily used for base maps, especially raster base maps. But more recently, it's something that we also see for vector data, and that's something I'll talk about here in a bit. The benefits of tiles is that both the client and the server can parallelize requests for data, right? The client can make requests for multiple tiles and multiple tiles worth of data at once, meaning you can take better advantage of your network. The server equally can also then respond to these by working on multiple requests at a time and potentially getting better throughput. And tiles are very heavily used in caching, especially classic cached map services. Instead of creating a fresh image for every single request, that, like we just talked about, you can pre-create images for each of these tiles, which makes it much, much faster to send back a response to the client. So let's talk about caching just a little bit. The two most prevalent ways of caching within ArcGIS Enterprise is by caching map services, what I was just talking about, caching those map images. You can pre-create a cache, or you can create a cache on demand in those cases. More recently, we've also had the ability to publish 3D layers, what we call scene services. And scene services are always pre-cached, and they're stored in what we call the blob store. So this is something that's been around for a long time and is very popular, especially for those base maps and especially for raster base maps. Such a cached map service in particular, they can be really big. So while we've been able to store these caches on file-based data stores for quite a while, for several releases, we've also supported the ability to store these caches in cloud stores. That's things like Amazon S3 storage or Azure storage. These cached map services, the caches can get up into the gigabytes, hundreds of gigabytes, sometimes even terabytes, depending on the level of detail and the area of interest. For a global data set with highly detailed satellite imagery, you may very well look at hundreds of gigabytes, if not terabytes worth of cache. So storing it in cloud storage can be very, very cost efficient and much easier to manage. Something new that's coming at ArcGIS Enterprise 10.9 is quite interesting. I'll talk more about feature tiles here later, but I wanted to just mention here as part of the caching introduction that this is something that we're introducing. There's going to be a new type of data store that comes with ArcGIS Enterprise called an object store that will be able to store these feature tiles, meaning they're not images that we're storing, but they're really pre-packaged bundles of feature data that we are sending back in response. So this is a really interesting new thing that we initially imagine will be used as a fairly advanced option, but it's definitely worth keeping in mind. I'll talk more about this later when I get to hosted feature services and what this really means. Now let's move on to the many different types of GIS services that we support within ArcGIS Enterprise. There's a lot of them. In this presentation, what I will focus on is map services, both those dynamic and tiled map services that I've mentioned already. I'll talk about vector tile services, and I'll talk about feature services. As I mentioned, there's a lot of other services, some of which I've actually mentioned as well. There's things like image, scene, stream, and geocoding services. That doesn't even begin to cover the wealth of additional, even more specialized services. We're not going to cover those in detail right now. We simply don't have the time. We'll focus on the meat and potatoes of GIS web services: map, vector, and feature services. Map services I've already talked about. It's this idea of making a request about the image you want returned and the server generating that on the fly and returning it to the client. It's that dynamic map service. Dynamic meaning it's always generated just in time as the client makes the request. This type of service powers the map image layer item within the ArcGIS Enterprise portal. Only ArcGIS Enterprise has this type of service. ArcGIS Online does not have the ability today to publish this kind of service. Traditionally, this was available for user-managed data only, meaning this was a type of service where you had to have your data in a relational database, an enterprise geodatabase of some kind that you were connecting out to. Beginning at ArcGIS Enterprise 10.8, however, we actually have the ability to publish hosted map image layers as well, meaning you can create a map service off of data that you've got within some of those ArcGIS managed data stores. The key capabilities are what I've mentioned throughout the presentation already. Server-side rendering. You can also do things like dynamic layers. You can actually ask the server to exclude certain data sets or include certain data sets that may be off by default as part of the drawing process. That's something you can specify as part of your request. While you can't interact with the image on the client, you can still make an identify or a query request against the server, meaning go back with another request to the server and say, at this location, what is the data that is present? It also supports OGC standard endpoints like WMS. So it's not just the Esri map service endpoint, it's also the standard WMS endpoint that many non-Esri clients will know how to talk to. Over the past few releases, we've added some very important new enhancements to map services. One I really want to make sure that everybody's aware of this concept of shared instances. Traditionally, when you published a map service to ArcGIS Enterprise, it came with a fairly high cost in terms of memory consumption in particular, completely independent of how many requests the service was receiving and the CPU consumption that such a request brings with it. It was always just sitting there waiting for requests to come in, and that took up a lot of memory per service. So there was often an incentive to minimize the number of map services you had on a system. With shared instances beginning at 10.7, that's really no longer a problem. We have this mechanism of pooling many different map services into a small number of processes running on the server so that you don't have that memory hit when you're publishing new services. This is the fail-safe option. Virtually every client in existence knows how to talk to these, and it can work quite well for certain use cases. Highly dynamic data, especially when you're on these constrained networks where you need a small payload going back from the server to the client. Then we have a variation of the map service, the one where it's tiled or where it's pre-cached. Right? The client makes requests for the individual tiles that the world or the area of interest have been broken up into and gets many individual tiles back that were pre-created in most cases. This is available for both online and ArcGIS Enterprise, and it can also be done for both ArcGIS and user-managed data. It's still rendered server-side, but it's pre-rendered. It's cached for the most part. And you can take these caches offline, and you can download subsections of those caches onto a mobile device and still have access to the layer when you're not connected to the network where your server is hosted. And like with a dynamic map service, we support the OGC endpoint for this. In this case, it's not a WMS, but it's the WMTS tiled service. And again, this is also kind of that fail-safe option. It's the good old standby for complex and static data where you need high performance. Slightly newer is the vector tile service. It's been around for a number of years now, and there's now quite broad support across the different clients for this type of service. It's available in online and enterprise, but something to keep in mind is that it's always going to be ArcGIS managed data in the sense that you pre-create your vector tile cache on the client, in this case ArcGIS Pro, and then hand over that cache to the system. The cache doesn't update automatically when your underlying data might change, so you need to have a process in place for updating your vector tile caches when you want to take advantage of newer data coming in. Unlike the dynamic map service and the tiled map service, these vector tiles are rendered client-side. So this is how you get a high-level interactivity. You can turn your map, you can rotate it, and the labels, for example, can still stay in place because the client is doing the rendering and has the ability to do those kinds of things. It's for visualization only. You can't do identifiers or queries against this because of the way that it generalizes the data and clips it to the individual tiles. But these vector tile layers are tiny, 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 tiny compared to a traditional cached map service. I mentioned before that a cached map service could easily be gigabytes, hundreds of gigabytes. In some cases, vector tile layers by comparison are often in the kilobytes or at most the tens of megabytes. I've seen a few in the hundreds of megabytes when they cover a really large detailed area, but even that is several orders of magnitude smaller than a cached map service. Very much worth keeping in mind. It's a great alternative to tiled map services in many cases. May even replace feature services in some cases. I'm not going to belabor this point too much, but the way that it achieves that small file size for a vector tile layer is by using some really smart algorithms for how to divvy up the data. You can kind of see that idea of how it supports overzooming and has an index tiling scheme in this image, where imagine those tiles that cover a large area of the ocean where there's really no data. There's no need to subdivide those areas into even smaller tiles because you've already got the full fidelity at a higher zoom level. To take a look at vector tiles, I'm going to hand it over to Whit, who's going to show us a quick demo and the difference between map services and vector tile services. Whit?
To illustrate the difference between map tiles and vector tiles, we're going to take a look here at the map viewer in a 10.8.1 deployment of ArcGIS Enterprise. So here we have the topographic map by default. You can see this here loaded within my map viewer. As I navigate around the map, you can see that all aspects of the map load pretty quickly. We can sometimes see things refresh in chunks as we zoom and navigate. It all happens quite fast. But if we look at what's going on behind the scenes, we'll do that using developer tools. As I interact with the map, you can see a bunch of requests here. Now, if I make this a little bit larger, you can start to see the type. And we can see here both JPEGs, and if we look at those, these represent the hillshade portion of the map. This is actually raster data, which doesn't really lend itself to vector tiles because it's a different type of format. It's pixels, not shapes. And so this is coded most effectively into a JPEG image, which is served as a tiled map service. But if we take a look at some of the other ones in here, we'll see PBFs. PBF is a compressed binary format called protocol buffers. If we click on these, it's really hard to distinguish what's actually going on in here because it's binary, but you can see some of these names here that suggest that what we're looking at here is actually the labels. So here the labels and some of the other overlaid features on this base map are being brought back to the client as a vector, which allows them to render fast, as well as gives me the control to come in here and actually change the symbology, one of the powers of vector tiles over map image tiles.
Thanks, Whit. That was really great. I'm going to keep moving right along and talk about feature services. I mentioned this during the conceptual part of the presentation. This is where a client makes a request with the area of interest, potentially a where clause, which fields it wants back, and then the server returns a response that has traditionally been based on JSON. This is the classic way of using a feature service, and this has actually evolved a little bit over the years. Today, what we see much more of is especially the web clients making use of what we call feature tiling. This is where the client itself makes requests for multiple smaller areas and makes those requests in parallel to the backend server. This enables the server to do a couple of things. One is to simply handle those requests in parallel and start returning smaller chunks of data faster. We call this feature tiling because it's the same concept as what we saw with the cached map services, where the area of interest is subdivided into smaller rectangular pieces. Another really big advantage of this feature tiling mechanism is that these tiles are standardized. That means the same queries are made by different clients coming and looking at the same area. This means that the server can, in some cases, start taking advantage of caching because it's the same exact query that it will be responding to over and over again from multiple different clients. So we'll see what that means here in just a second. Feature services is what powers the feature layer and the table items within the ArcGIS Enterprise portal. The feature service is supported by both ArcGIS Online and ArcGIS Enterprise and from both ArcGIS and user managed data sources. So you really have a lot of flexibility here. The client is rendering all of this data. You can do identifies and queries. You can do generalization, meaning you can ask the server to not necessarily send you the full fidelity features back if you're showing them at a very high zoom level. You don't need all of the vertices necessarily. They support editing, they support taking data offline, and they also have that OGC standards compliant endpoint, the WFS endpoint available to it. And then in the last several years, we've done enormous optimizations in terms of how performant a feature service can be within ArcGIS Online and ArcGIS Enterprise. Something that really should make you consider using feature services much more than what you might have done in years past. This really is the standard for dynamic operational layers as well as any kind of layers that needs to support editing. Those optimizations that I talked about and are shown here on the slide, quantization and PBF, can be a little bit hard to explain with words. So instead, what I want to do is turn it back over to Whit, who can show us a really compelling demo of what quantization and PBF does for us.
To demonstrate some of the improvements in feature services over the last several releases, we're going to look at two identical maps. The first one here is coming from a 10.5.1 deployment of ArcGIS Enterprise, and the one we'll look at in just a moment is from a 10.8.1 deployment. So we can actually look at the difference in performance and experience over the last several releases. So again, here we're looking at a 10.5.1 Enterprise. This is a map that visualizes all counties in the United States. And there's about 3,200 of them. So if I zoom out here, you can see that the map loads reasonably quickly, but even at this scale, it's starting to get a little bit sluggish. You can see around the borders, it's taking quite some time to populate those counties. And if I continue to zoom out, this map is actually going to take quite a while to complete loading. It's actually trying to bring back a lot of data right here, and it is getting a bit sluggish. Now, if I switch over to the 10.8.1 map and do the same thing, you can see still loading quite quickly. I keep zooming out, and there it loads very fast, almost actually as fast as some of the base map tiles. But to really understand what's going on here, it's better that we bring up developer tools and actually do this without any browser caching involved. So I'm going to empty my cache and do a hard reload here. Now pay attention down here, if you would, to the amount of data being transferred over the network. So again, here we're looking at the 1051 map. Just going to keep zooming out. You can see it's already transferred over 10 megabytes to my browser. Still going. And yeah, now without browser cache, you can see it really struggling to load this map. It's now almost at 40 megabytes worth of data. And as I start to interact with the map, it's maybe a little hard to tell through video, but it definitely feels sluggish. It's like the browser is holding back my mouse in a way. And there we go, over 50 megabytes. Now let's switch over to the 1081 map and we'll do the same thing. I'm going to empty my cache and reload. And we're going to zoom out. And I'm just going to go faster here because it will let me. There we go, map of the United States, less than 6 megabytes transferred, and you can see that it's really snappy and loaded very quickly. So to see how that worked, I'm going to filter here by the query request so we can see what's going on. If we look at one of these, the first thing we'll notice right away is that it's coming back as protocol buffer format. So it's already a compressed binary format, which helps it minimize the payload over the network. But let's actually copy this link and we'll bring this up in, it's hard to read the PDF. So what we'd like to do is take a quick look at the JSON representation. All right. So if we look at the results, look at some of these geometries coming back. You'll see that the geometries here are actually rings. They're polygons representing counties, but these numbers don't look like real world coordinates. These are actually what we call quantized coordinates, which means that we've essentially mapped the real world coordinates into a virtual coordinate space so that we can be much more efficient. We don't need all of the digits present in decimal degrees or Web Mercator needed to represent real world coordinates because we just have the screen to deal with, not the world. So that allows the numbers to become much smaller. You can see here that the coordinates also look absolute at the beginning. We have 33 and 54. And then you can see here as these coordinates are really more like pen movements than they are actually absolute, even virtual coordinates. So that again further compresses the size. And then there's also an opportunity here, once the coordinates are mapped to this virtual space, to remove coordinates we don't really need anymore. So there is also some logic behind the scenes to basically remove coincident and collinear vertices. So all of this serves to really compress the amount of traffic that goes over the wire and allows you to deliver more vector capability in a way to the client that not only can you visualize quickly, but it also supports real-time query and analysis. And to really demonstrate that power, we're looking here at a sample that's available in the JavaScript API, so you can check this out on our developer website. Here we have feature service representing homicides in the greater Chicago area. Now, of course, it's an interactive map, and I can visualize it. But if I click on the map, you can see that it does a query, and as I drag that around, it's updating the map in real time. It's actually doing on-the-fly query against the features in my browser. Nothing's going back to the server, and that's why as I'm dragging this around, you can see all of this data updating in real time, both on the map as well as in the chart. So an additional power of feature services and what we often call feature tiles, because these features are in fact delivered as tile to support better caching both in the browser and on places like the content distribution network and the server. that it allows you to do those queries in real time.
If that kind of demo doesn't convince you to use feature services more or potentially upgrade if you aren't already on one of these versions of ArcGIS Enterprise, I don't know what will. It really is one of the biggest leaps forward in terms of performance that we've had in many years for this kind of service. This slide here kind of summarizes what Whit was just showing. I'm not going to read it all out loud. It's dense for a reason, and it's intended for you to be able to refer back to here after the presentation. What I would like to actually talk a little bit about is some of that caching that I mentioned earlier. So coming at 10.9, what we'll have is the ability to set up a caching mechanism for hosted feature tile requests. So this will be an advanced option that system administrators can take advantage of. We consider it an advanced option because there are some nuances to this, like everything in this presentation. This is for hosted feature services only. And you really have to understand when this caching will be of use for you, when you'll actually see a benefit. Basically, it boils down to your data can't change too often. If your feature services are exposing editable endpoints where many clients will be editing data on a regular basis, then caching the intermediate data really doesn't provide a lot of value because you have to throw away the cache on a regular basis every time somebody makes an edit. So we do consider this an advanced option. But if you have high throughput and scaling requirements, you're using hosted feature services, and they're not changing every few seconds or every few minutes, then this can really kickstart or boost your throughput in many cases. I want to also just quickly show these tables. Again, I'm not going to read it all out loud. Quantization, this is something that Whit just showed you. It's supported basically on everything, any kind of map and feature service from ArcGIS Enterprise 10.6.1 and higher. So it's a pretty simple table. Lots of green on here. PBF support, while not quite the same level of performance boost as quantization itself, it's still a very significant benefit if you have the right types of services and clients. Again, here they're supported. PBF output is supported for pro-based map and feature services from 10.7 onwards, and also for hosted feature layers from 10.8 onwards. If you're publishing from ArcMap, this is one of those examples of where I highly encourage you to move to Pro to be able to take advantage of these under the hood improvements, because they're coming in from the Pro and hosted sides only. Just a small nuance that I feel is often far too overlooked, and I want to make sure that everybody understands, is that there's a distinction between a feature service that you're publishing on the server and a feature layer, what you're using in the client to draw these kinds of underlying services. While most often you will see a feature layer in the client buddied up with a feature service on the server, that doesn't have to be the case necessarily. In fact, all of you have what essentially amounts to a read-only feature service for every single one of the map services that you've already published. You do not have to publish a feature service to take advantage of many of the concepts that we've been talking about here. If you don't need editing or the ability to take data offline, pointing to an individual layer inside of a map service is completely identical in behavior to your feature services. So really encourage you to dig into this and understand what this means so that you don't have to reauthor a bunch of new things, but still can take advantage of that rich client-side interactivity. All right, let's try to wrap everything up and summarize what we've been talking about. I want to go back to that initial idea of putting together a publication strategy that's driven by business and IT requirements. In other words, those business requirements keep in mind what your end users are trying to accomplish, the devices they're working with, the kinds of infrastructure they're working with, and then using that information to drive the decisions on the technology side in terms of GIS services, which type of service, how to do caching, if to do caching, making use of generalization, making use of other options at the portal information model level that I unfortunately didn't get a chance to cover too much here. A good publication strategy ensures that you are delivering the right content to consumers in a way that meets their expectations for performance, scalability, reliability, and security. Take that business first approach. I really want to encourage you to use ArcGIS Pro as your primary publishing application. There's so many under the hood improvements that come in via pro-based services that you will be missing out on if you're continuing to publish from ArcMap. While we didn't talk about it a whole lot here in this presentation, keep the geoinformation model in mind. Web maps and layers can really help you also avoid having to publish additional services in many cases. Take a look at the ability to style things at that level without having to style things in Pro and publishing entirely new services. And then keep those newer options in mind. That's really the main point of this entire presentation. Feature services have far more functionality and much better performance than you may remember if the last time you looked at them was several years ago. If you're still using cached map services for anything other than your raster base maps, then you should consider using vector tile layers. Take a look at how incredibly powerful they are. They're so much faster to generate. They're so much smaller to store and send over the network that they're almost always a pure win. And then, as you can tell, publication is a nuanced and evolving topic. Every release we make improvements, provide new options that make these decisions maybe slightly more complicated to wrap your head around initially, but really provide a lot of powerful capabilities. Thank you so much for joining us today. I hope you enjoyed the session. Hi, thank you for joining us today. My name is Philip Heedy, and I have Whit with me here to help answer your questions throughout the next 13 minutes or so for our Q&A. Let's jump right into it. We've got a really good list of questions, and I can already tell that we're probably not going to be able to make it through all of them, but we'll take as many as we can, and then we'll try to follow up with those of you who have your name on there and see what we can do afterwards. So the first question that's been upvoted is about automating publishing of data from an enterprise geodatabase to ArcGIS Enterprise and making it available as not just services but also items within your portal. And it's a great question because we've actually got some functionality that we added in the not too distant past. We added what we call bulk publishing with ArcGIS Enterprise 10.7.1. So it's a very simple, straightforward way of essentially pointing to an enterprise geodatabase and then taking all of the individual feature classes there and creating map and feature services out of them. One map, one feature service per feature class. If you need more control over the publishing process, then you would have to go through a more traditional automation route, such as writing a Python script, for example, and iterating over your data sets and doing whatever it is you need to them as part of then publishing. One of the next questions on here that I wanted to hand over to Whit is what are the pros and cons of feature tile caches versus vector tiles? Whit, is that something you can talk a bit about?
Yeah, thanks, Philip. This is a really good question because there are a lot of similarities between these. They both work in tile fashion, which means they lend themselves well to caching at the browser tier and potentially at other tiers. And they both contain vector data, but feature tiles actually contain the original representation of the data. Vector tiles involve clipping and things that happen, which does in a sense affect the original integrity of the features, which means that in order to do more work with those features, they need to be reconstructed on the client. when it comes to the capabilities of the tools that we make available through Esri, you're able to do more with feature tiles because we actually get a representation of the data into the browser, and we can work with it like we would if it were just having Pro connecting to a file geodatabase. We have the data there. And that was, I think, evident maybe in one of the later demos we showed. But I guess back to the question, like pros and cons, we increasingly see opportunities to use feature tiles. And when it comes to data that's changing a lot, I think definitely feature tiles should be something you would look towards. The performance of vector tiles does tend to be a bit better. Kind of see from the demo, in that example, feature tiles did actually load almost as fast as the base map vector tiles, but you're still going to see vector tiles loading a bit faster. Also, if you're talking about something that needs to be highly scalable, like a base map, you can serve more with less infrastructure using vector tiles because it's all pre-cooked and pre-cached, and it's just handing out tiles. So I think it kind of depends. If you have static data that's not updating very often and lends itself a bit better to either something that needs to be super fast or super scalable in terms of serving large portions of users, you probably want to look at vector tiles. But for most of the other use cases where you have like kind of operational data, we think feature tiles is a really good fit. So there's maybe a few pros and cons to consider.
Awesome, thank you, Whit. The next question on the list here is about when to use an enterprise geodatabase versus the built-in ArcGIS data store for your data, and whether there's performance differences or anything like that. It's a really great question. Again, there's different pros and cons, and both options are suited for different kinds of needs. We actually wrote a technical paper a few years ago on this very topic that I would highly encourage you to take a look at. It's called Data in ArcGIS, User Managed and ArcGIS Managed. And I'll put a link into the chat here for all of you to go through. It really speaks a lot to not just this, but also some of the other considerations in choosing which one of the options to go for. Next up here, I wanted to, maybe this is a simple one to take off the list. If a feature layer is published from an enterprise geodatabase, can a user with a viewer, user type and a viewer role edit that feature layer? And I think it's an easy answer, right? But
you need the editor type, right? Okay.
Yes,
yeah.
Exactly. A viewer can only view. To do anything more than interact with the data, you will need an editor or hire a user type. Another question here is about that transition from going from ArcMap to ArcGIS Pro. We pointed out a couple of examples of where Pro-based services have different kinds of advantages, and whether we have resources for how to do that migration. There's already a lot of really good resources within the Pro documentation itself. You can open an ArcMap MXD with ArcGIS Pro, and then you can take that and publish the corresponding service again. There's a lot of other details to it, of course, but the Pro documentation actually speaks a lot to this. Something we're working on right now, in fact, is more of a technical paper to really go through the different types of services and exactly what's being asked for here. How do I migrate for the purposes of preparing for the releases in 2022 and beyond, where the ArcMap-based services will no longer be supported? So stay tuned for that technical paper. It's something we're going to be publishing on the ArcGIS blog and through other channels here over the next couple of months. Whit, here's a question that I think you can also help us with. It's really a question of infrastructure and the limitations. Is there a limit to how many map services an ArcGIS server can support? Is it 200? And then kind of the corollary to that, is it better to group layers together many layers together in a single service to kind of have fewer services versus splitting them apart into one layer, one service?
Yeah, that's an interesting question. The way we would have answered this a couple of years ago might be different, because at that time, just about every instance of a service had a SOC process associated with it. And that meant that it really was a memory consideration more than anything, how many services you could in practice deploy. I had at the time definitely seen more than 200, but you would reach a point where in practice, like the machines that you could get and the types of services you would publish, you would hit a practical limit. So there wasn't any real limit in the software, but there was a practical limit as to how many a given piece of infrastructure could support. Because it was largely memory related, I think that was something we acknowledged a few years ago, and did quite a bit of work in the product to allow you to have more services and more efficiently switch between them, so that you didn't have one SOC process per one service instance. It became sort of this idea of a shared instance where you could dynamically run different services. And that really changes the calculus here quite a bit. I don't know if Philip, you want to maybe just quickly introduce shared services as a product capability. I can't remember if that was 10.6 or 10.7 offhand.
Yeah, absolutely. Shared instances were introduced with 10.7, 10.7 and higher. And like you just said, it's this idea that before there was a strong relationship between a service that you published and the service instances that powered that service. Essentially the processes that ran on the server in order to be able to respond to requests. And each one of those instances came with a memory cost. So the more services you had, the higher your memory consumption was. It wasn't necessarily linear, but you always incurred that memory cost when you published something new. So there was a lot of things you could do to tune that, to try to lower the number of instances, setting things to min instances equals 0, which had other effects such as higher startup cost. The first person to make a request suffered some lag before it was ready. Shared instances really is a game changer, because it means that there's always a pool of processes ready to answer requests for any service that is part of the shared instance pool.
Yeah. So if you have some services that like are fundamental dial tone services for your organization, you may still consider publishing them as dedicated to ensure they have dedicated resources. But for a lot, I think a lot of the data that we use and publish on a regular basis is sort of used in more of an ad hoc manner, and we think dynamic services or shared instances will really help that. And so back to the question of like, should you group them or not? It used to be the case that you had to be quite a bit more thoughtful about grouping, because you could only have so many services in practice, where I think now that practical limit is in effect gone away. And I think you can look at less grouping if it makes sense, but then there are still some trade-offs with regards to like how easy it is for you to operate and manage these. There's, it may be easier for publishers to own certain collections of them and publish them at once. But I think there's fewer and fewer hard rules or even like real limits to deal with. It's more a matter of what makes sense for both your publishing workflows, your operational workflows, and the way that applications consume it. So there's no hard best practices there. It's sort of what kind of works. There's a lot of flexibility, I think.
Yeah, absolutely. Thanks, Whit. And another consideration is often that by having one layer per service, you also aid in discoverability within the portal itself, right? Yeah. It's much easier to search and find those things when there's a single item per data set. But then it comes with the overhead of not so much the memory on the server anymore, but the overhead in terms of managing it, like you just said. We have a time for maybe one or two more questions. There's an easy one that's been upvoted here. ArcGIS Pro, does it allow overriding existing services that were originally published using ArcMap? The answer is yes. You can override a map or feature service that was published using ArcMap with ArcGIS Pro. So you can essentially take that MXDN that you used to publish the service originally, open it using Pro, and then publish the equivalent service again using Pro to switch it over. One thing to note there is that beginning at 10.9 here, due to be released shortly, it'll actually be possible to switch certain types of map services and feature services from running under the ArcMap-based runtime, if they were originally published from ArcMap, to then running under the pro-based runtime without having to republish it. So instead of necessarily going through tens or hundreds of services to republish them, you may want to take a look at that option when it becomes available to you. And with that, I think we're pretty much out of time. We still have a lot of really great questions. Like I said, we'll try to follow up on the questions where we have your names. But again, thank you so much for joining us today. We appreciate your time, and we hope you have a great rest of the conference.
Thank you very much.